So when I talk about the bulk of the manufacturing, what you're going to be doing, as explained in the workout, basically is we're going to rough out the OT using dynamic milling. We're going to finish it using contour. We're going to face it, and then we're going to do our drilling and we're going to break the edges too. I think I called it out. So the actual manufacturing part of it is not too complicated. Ooh, there we go. Get in. Hi, Emily. Good evening.
Hi, Sean. Good evening, you guys.
Thank you. We're just starting to go over the document for the week.
You got it.
So for Op 20, we've already created that folder. Okay, same deal. This is the, so Op 20 is where we'd actually be facing the part. This is the one we're not going to build for SolidWorks. Okay, so it just doesn't make any sense. Op 30 is the one where we're actually going to flip the part 90 degrees and do the drilling, and that's the second one that we're going to build in SolidWorks. Okay. The stock is going to be 4.5 by 4 by 7/8. Again, which gives you plenty of room for work holding, so you don't need to do any standing. The planes, you're going to have to make 3 planes, G54, G55, and G56. And each of those planes are going to be located in the bottom left-hand corner of your part. And it doesn't matter how you orient it, it still should be in the bottom left-hand corner. There's really only one, usually most people do one of these corners here. But the only thing I care about is that you're working in the positive plane. So if you're looking at the Cartesian coordinate system, I want you working over here. So your 0, 0 point's always going to be in the bottom left-hand corner. And for this part, as I mentioned, there isn't a square corner that you can easily grab onto. So you're going to have to draw that reference geometry that we did the last time. So we have intersection points. Or you can offset it and do it manually with math in your head if you want to. But I always like to just draw those 2 intersecting lines that you can snap the plane onto. Okay. And we'll talk about that in class too as we're working. So you're going to have some reference geometry to build. G54 is going to be the top of your part. You can basically copy that plane, duplicate the top plane and make that. And then the other 2 you may just want to make from scratch from solid, and then just make sure the Z plane is oriented the right way. Levels is going to be important. So every time you merge a solid file into the assembly, the very first thing that you want to do is turn off the layers for your first operation. So it looks like a clean slate, like there's nothing on the screen. When you merge the second assembly into it, you want to rename those right away so you don't get screwed up. Okay. And this is why having the operation 10 suffix or prefix in that level name is important so that you know which level that refers to or which operation that works at. So when I'm reviewing Op 20, I go into your tree, I move that red insert flag into Op 20, I make sure all the levels are turned on for Op 20, and then I backblock. That's how I check. And that's basically the thinking that you want to do too, going forward. For toolpath, like I said, I pretty much give you exactly what to do for toolpath. So we're going to face to establish V0. We're going to use the largest angle possible, which is dictated by the size of the features on your part. So in this case, I do not call out a separate toolpath for the slot. All right. So what that should tell you is that anything under this size here that's realistic can be used to manufacture this feature. Okay. And what I want you to do is maximize that. What I don't want you to do is just to pick a 1-inch end mill and just throw it in there, because as we've talked about, if you're using a 1-inch end mill on a 1-inch feature, all Mastercam is going to do is just kind of drive into it. And that means that the size of your end mill is dictating the feature and not the actual tool path. So you want to make sure you use something that is smaller than that feature. Probably 7/8. There's probably a 7/8 end mill in there. I'm only going to call you out if you use a 1/4 inch end mill to machine that pocket or something like that. You know, I want to see you at least trying to maximize your ship load and stuff on the tool size. I give you all the like the Z information here, but what I don't do is call out all the linking parameters that are normally standard. So I do mention up top, you know, make sure your clearance is always 2, your feed and retract are always a 1/4 inch absolute. And that's the big thing, is make sure you're always working in absolute. Okay. Otherwise, I give you basically the breakthrough amounts and things like that on the Z. I don't dictate a lot of the step over stuff, because most of that is going to be set up by default. You don't have to mess around with that, but you can leave the 90% step over. Okay. Brake edges is kind of a pain in the butt. There is a video on YouTube where I cover that from last semester. Most of you probably remember doing this. You basically have to fake it in using the profile of the tool. So if you get to that point and you have an issue with breaking the edges, I will repost that video that explains how to do that, so you have it. And we can talk about it today too if you get that far. Okay. So this is the important part that we're going to start building right now before we get going by ourselves. So Op 10 is going to be a machine group. Okay. From our conversations, remember there's 2 different groups in that tree. One is the machine group and one is a toolpath group. And we get kind of mixed up on this tree often. So this is why I want to harp a little bit here. A machine group is basically when you first put a part into the machine and you have a stock block, you have your parameters, and you specify a post file. So what I mean by that is when you're in Mastercam and you go up and grab a machine group, you go to machine, you go to mill, and you bring in the stick mill 3X, that is a group. Okay, so that is one standalone machine. If you put toolpath groups underneath that, basically what that means is you're going to stay in that machine, but you're basically rotating the part, or you're not taking the part out of the machine really. It's staying in that same area. If you do a second machine group, what that kind of virtually symbolizes is you taking that part out of that machine or out of that cell, bringing it over to another machine, and you can actually have a separate stock block. You can have a separate post file. You may take this out of a HOF and put it in like a Danichi or something like that. It may be a totally different setup. Okay. So the way I'm doing this with this lab is we're kind of virtually saying that we're going to do a couple of operations in one machine and then the last operation in another. Okay. And again, it's just to get you comfortable with what those 2 different things are. So machine group 1 is for Op 10. Okay, so we're going to do the basic machining, or most of the bulk of the machining in that one machine group. For Op 20, we're going to make another machine group, and we're going to create another stock block, basically. Okay, inside of Mastercam, not inside of SolidWorks. So again, this is where it's going to get fun. After that, operation 30 is a toolpath group and not a machine group. So that one's going to stay in that machine. So you're going to have one machine group for your Op 10 and a second machine group for Op 20 and Op 30. Trust me, you'll get there. Okay. Okay. And as you read this, it might walk through it. And we're gonna build these right now so that you all have the same structure. So it's not that big of a deal. But basically, what I'm trying to do is save you some time on the Op 20. So instead of having another SolidWorks assembly and another machine group, we're just going to do that one roughly in another one. And then Op 30, you don't really need to have stock because your part form is already there. The only thing you're doing is drilling those 2 holes. Okay. This is where it starts getting a little advanced. Okay. So we got plenty of time to work on it, so don't worry about it too much. So to get everybody just set up on what that structure looks like in Mastercam, what I want you to do is open a new Mastercam file and we'll kind of build that and we'll look at it now, okay, before we go too much farther. So when you open a new Mastercam file, what I want you to do is very first thing is just to save it. So I'm going to save mine, and I'm going to put this in that same working folder, but I don't really care if it's in one of the operational folders. It's kind of its own standalone thing. So just inside of like my week 4 folder where I can see my op 10, op 20, and op 30 folders, that's where I'm going to save the Mastercam file. I don't want to bury it too far in, so I'm looking for it later. Oh, you talk. What? That's the name of the part. You put your last name in there if you want to. Whatever helps you stay organized is the best thing that you can do. So once you've saved that Mastercam file, we're going to go ahead and bring in that first machine group. Okay. So in order to do that, you would go to the Machine tab. You go to Mill, and then you're going to select the Stick Mill 3X. If you're at home and you don't have the post, you can go ahead and just use the default one. That's perfectly fine. Again, if you were going to generate code in school, you could always come in here and change that file in here and actually make it generate the Haas code later on. So everyone should have machine group 1. The toolpath group 1 that comes in with this machine group, we're going to rename that immediately. Okay, so that's going to become our op 10. I'm going to double click on toolpath group 1 and rename that to OP10. Okay. Now, once you have done that, we're going to build the second half of the project. And again, that's when I mentioned we're going to have a second machine group. So all you need to do is go back up to Machine, Mill, and then reselect that Mill 3X again. And then you'll see machine group number 2 comes in. Okay. You could do this in separate files, right? So let's say you wanted to flip this out. I don't really care if you had more than one file, but I just want to show you that it is possible to do it all in one. And it's kind of nice to keep the entire project in one structure, and so you're not having to go look for different files. And I'll also show you how to post this separately too. So you can post these separately without any issues either. So our machine group 2 also comes in with a default toolpath group. Okay. So under machine group 2, we're going to rename this toolpath group to op 20. Okay. After you rename that toolpath group to op 20, we need one more toolpath group underneath it for when we establish the 90-degree flip of the part. Now, this is where you want to be careful. You want to make sure you net the toolpath group for op 30 under the second machine group. So what you do is you have to left click on machine group 2 to highlight it so it's gray. And then you can right click, go to groups, and then go to new toolpath group. Okay. Now that should show up right underneath your op 20. It asks you to rename it right away. It comes in blued out so you can rename it. And that's going to become op 30. Now you can clearly see the difference between the toolpath group and the machine groups, because the machine groups have the properties box or tree level underneath them, and the toolpath groups don't. Okay. So this is where you can establish different stocks and things like that in different machines. So you notice now you have the opportunity to have 2 different stock setups versus if you did a toolpath group for all 3 of these, you can only have that one stock block in Mastercam established, and that's all you have available, which is fine most of the time. But if you're building fixture assemblies, what that means is if you want to work in that same stock block, that means you actually have to build the fixturing around the stock and the parts versus just making a new one and building the stock for whatever setup you've already got done. So that's kind of why I like to do it this way. Some of the files that I've seen from the day class, they keep the stock and the parts in the same location. And then they have different fixtures basically flipped, all around this way, which works. It's fine. But I just kind of like to show people this way. Okay. When you go to actually generate your code, when you actually hit this G1 button, it'll generate the code for any machine group that you have in here. So if you just want the code for machine group 1, so that's machine number 1, you highlight it, you click the G1 button. I forget if it asks you or not, whether or not it actually may not do anything because I don't have anything selected. There's no toolpath groups. But you can create 2 separate code files out of this one group, right? It's not going to come out all at once. It gives you a new safety block and everything else, a new file name. So it's almost like having 2 separate files. It's pretty close. So this structure here is basically what I tried to explain in writing, but it's not easy to explain, right? So that's why I'm recording this, so you can kind of watch it later if you've got any issues. So I'm going to save this and kind of open it up for questions about any of this setup. Does anybody have any questions about what we're trying to accomplish with this structure?
Nothing from me.
Doing okay? Okay. And like I said, we're not on anybody else's timeline, so we can take our time. Just try to stay organized. That's the biggest thing. So now what I want to do is I want to show you how I set these up in Mastercam. Obviously your SolidWorks files are not set up. Okay, so I'm just going to import a couple of vices and kind of show you how I set this up in my own space so that you can kind of emulate the same thing later on once you have your assemblies fully built. Okay, so I'm going to pretend that I have my assemblies completed, and now I'm going to merge my first Op10 files in, right? So I'm going to go in my Op10. I'm going to change the filters so that I'm looking at SolidWorks stuff or everything. And I'm going to pretend that this Circle Curt vise is fully loaded and ready to go. Okay, so I'm going to drop that in place. So now again, I have, actually, I forgot I have stuff in here, so it's all right. So it does look kind of like it's going to. So you still have that 90-degree move you have to do, right? So I'm just going to follow through this quickly because this is not basically what I'm trying to show you. So I'm going to rotate this, my 90. I'm going to move the corner of my vise to the origin point, no big deal. I'm going to make a plane. And maybe this will give you an idea of how fast you can go once you get used to it, because it's really not that bad. I'm going to throw that on there. And then all my levels should have some kind of Op10 in front of it. And I'm not going to
John?
go through. Yeah, go ahead.
Yeah, do we follow you now, or we?
No, I'm just showing you. No, I'm just showing you what you're going to do with your full assemblies once you're done.
Okay, cool.
Yeah, so you just kind of watch and kind of see how I set this up. So for this part of it, when you're working on the solid, you don't really care. We're not doing anything with the machining tree, right? We're just setting up the parts. So here's my first assembly, right? Reflect. Clear colors. Okay. I would recommend setting these up before you start actually machining, just because it's easier to stay in this headspace and doing your movement stuff before you start actually applying toolpaths to it. So this is my Op10, right? Because we're making our own G54 planes and stuff like that, we don't really care where in space these SolidWorks files live in Mastercam. what I mean by that is we're always going to be starting from zero at the machine, whether this thing is over here or whether it's up here in space or up here in space. It doesn't really matter. Okay. Does everybody kind of understand that? We're not working up a reference. There's no real reference point in Mastercam aside from that WCS. So you make that and it's zero. So what I normally like to do is I'll just try to offset my assemblies in the X by a set amount, just so that they're not on top of each other when I'm turning them on and off and looking at stuff. And the way you can picture this in your head is you picture the machine, picture you've got X amount of vices on your table, right? So you got three operations, you're gonna have like 3 vices sitting on your table. And that's how I like to set it up. So I would save this. I would forget my Op10 exists. You know, I would just turn all that off and pretend it's not there. Now I go back into File and Merge. I go into my Op20, and then I bring in the build that I would for this Op20, right? So same exact steps, right? Again, you forget that Op10 is even there. You'll see that these come in blank again, right? So it doesn't matter. Now I rename all these for Op20. In our case, it's going to be Op30 because we're going to skip past the stock slip part for that. I kind of actually wish I had done that differently because probably going back and forth like that's probably going to be confusing. But. So now we do that 90-degree rotate again. And again, I'm going quick just because this isn't what I want to show you. I move to origin just to establish myself again. So I hook up the bottom left-hand corner of the vise to that reference point just for the hell of it. And now what I like to do is just pick a number that works for me depending on the size of the apparatus I'm working with. I'll go back into that same translate dynamic that I usually do. And I will choose a certain distance in the X to kind of move these things over. You don't want to do like 100 because then you can't see everything all in one spot, right? So I will just take the edge of this. I'll click on the X and maybe I'll just do 12 inches or something like that. Okay. And we'll walk through this again. Basically what I'm doing is the same dynamic that we use for rotating. But what you can do also is if you're just doing a linear move, you just click on that axis that you want to move straight across, right? So rather than using the arcs in between these axes, you can just click on the axis itself to do that. All right, so now what we just did is we have our 2 setups here, and they're offset in such a way so that if I want to see all of them, they're all in that same space. And then same deal, I would just come into planes again, duplicate top. This would be the G55 or G56, depending on what we're doing. And then we just attach that to whatever solid block we're working on. Okay. So once you get your head wrapped around the concept of it, you can kind of see how fast this moves. It's not super difficult. And again, what this does is it gives you the power to create an op sheet or have a visual for your operator so that when you are establishing this stuff, the SolidWorks background you do on the front end gives you a lot of powerful tools on the back end to show your operator. This is what it's supposed to look like. You can balloon these if you needed to, if you got to make an actual blueprint or something out of here for an op sheet. You give them the part numbers you need, the tooling they need, you give them the fixturing items you need, the stops, the T-blocks, whatever, all that stuff. That's where the SolidWorks stuff is important, right? Anybody can come in here and have a part in space and just say machine this, but it doesn't give you enough information to actually do it. You know, if you're not helping them with the work holding and telling them how you think you should do this to keep your tolerances and to do all that, you're missing a big chunk of the manufacturing process. So that's kind of why I like to include this in the night classes. All right. They don't do a lot of fixturing stuff during the day. So to compensate for us not being on machine, we get to do more stuff like this. And again, for this part, you know, big deal, whatever. But so this is the kind of stuff that I'm looking at doing with you later. Oh, I don't have it here. Damn it. Doing weldments and stuff like that is where this is important. And I have a couple of weldments that I'm going to upload that we're going to do that will allow us to utilize solid stock and things like that more, so you can kind of see why this is powerful. Okay. On this part, again, it seems kind of funky, but we're kind of doing simple stuff to start off. Trying to think if there's anything else in here. That's basically it. So when you go to do your stock blocks, okay, I guess that's the one other thing that I talked about before I let you guys start building. So your Op10 stock block is going to look something like this, right? So you've already got, you know, you got your full size block. You go into stock setup. You can go to, I think we did what? I think we did bounding box last time. It's the easy one. You click on your stock block, and it basically makes your stock display. Let's do wireframe. There. So there's the Op10 stock block. Okay. Now I think that all makes sense to everybody, right? So we, where is it? There it is. So that's what we normally have. We have one stock created. Okay. Now, since we have two machine groups, though, you can also come in and make a stock block for this one. All right. Your stock block for one of these operations is going to be light 60,000, meaning you're already going to have the 60,000s off the top, right? And if you were going to manufacture this and have a correct visual, you would actually draw a separate stock block that's 60,000 taken off. So if it's 7/8, it'd be down to 813, something like that. You would actually draw it at that size as an intermediary step for your stock. And then same thing, you go back into stock setup here, and you can establish that stock on your other assembly on this side. Selection, oops, undo. I clicked the wrong thing. Rectangular, bounding box. There. And then I go in there and I'm going to show you, I'm just going to turn this display on the same way. So display wireframe again. And then I'll turn it off again here. Okay. So it's going to show you your stock block depending on where your red insert flag is. So right now I'm in my machine group 2, right? So it's showing me my my second stock here. If I come back here and start working on machine group 1 again, it switches back. Okay. So you can have both those setups in the same thing. The next thing we're going to start looking at, which I'm not doing with you now, but you see this bottom left-hand corner called view sheet. So this is the next thing we're going to look at once we get this down, is you can actually create a view sheet for each operation, which is basically kind of like a tab that you can basically isolate your operations in. So let's say I wanted to have an Op10 here, and I only want to see my Op10 stuff, but I want to be able to switch back and forth real quick between a bunch of operations. The way that works is you turn off your Op10, the rest of your ops, only so you have Op10. Do this. You can right-click it and save the view sheet so that it knows what you're looking at and what you want to see. I come down here, I can do the same thing and make one for Op20. It's not going to look any different because I had the same thing loaded twice.
You just basically screenshot what you got.
Yeah, basically in a nutshell, yeah, almost, yep. So basically you can save, here you go, save this. You can save your operations and switch back and forth. See that? This is really cool when you've got like 4, 5, 6 ops on a part. You can isolate them. You have, again, like I said, you have them all in one file, and you can create op sheets and things like that and your code separately for every single operation that you do. And it's all right here, self-contained, right? Versus doing this 6 times in 6 different Mastercam files and not having it all combined. Okay. So while the initial learning curve on this is a little bit rugged, I'll call it. Once you get comfortable with it and you do it for a little while, like I said, it took me all of 5 minutes to set this up, and you will get to that point. I'm not anything special when it comes to this. It's just a matter of sitting down and doing it multiple times for however long you want. How can you want to get at it? Okay. This is where I'd love to see you guys at the end of the semester, is being able to do stuff like this on any kind of parts. You know, once you get used to the steps, the parts can be as complicated as you want. It's still going to be the same general process. At this point, I would be ready to start applying my toolpath to it, right? So I go in my op, I'd make sure my insert flag is in the right area, and then I just started going to town machining wise. Okay. In order for this to work nice and cleanly, though, you have to have an idea of what you want to do in your head already. All right, you don't want to go into this wishy-washy saying, well, maybe I'll machine it this way, and maybe I'll put it in here and do it this way. Because if you decide you want to change your mind halfway through, you're a hose, right? Basically, in a nutshell. So you want to make sure you establish what you want to do early on, think it through well, so that it reduces the risk of you having to change the solid structure or the positioning of this thing and your fixturing halfway through, because otherwise it's going to be a bear to get it to where you want it to afterwards. Does anybody have any questions? No? Okay. Now, as I said, the important part today for me showing you this is just to show you what the end game looks like. As you start to do this, you're probably going to get hung up on things, and just grab me and I'll help you set this stuff up. Okay. For today, if you get your op 10 set up, I'd be stoked. If you can get all of them done, that's fine. Preferably, I'd like to have you leave today's class with at least an idea of how you're doing the SolidWorks stuff in the start of the Mastercam. Because if you bump into an issue at home, it's harder for me to explain this stuff through email. Okay. So what I'd like you to start with is just read through a document again on your own. Come up with a plan. Everybody's going to have the same plan, I think, basically at this point, because I pretty much constrained it pretty heavily. You're going to put the part in you're going to make the stock block first, right? So start off by making this 4.5 inch by 4 stock block. You're going to save that in your op 10 folder. And then I basically want you to just spend a few minutes thinking about your parallel size. Now you can experiment. You have a couple different sizes of parallels right now too. Bring it in, assemble them, see if you like it. I'm going to give you a hint. It's probably going to be somewhere in the 1/2 inch to 5/8 range, right? You want to make sure the part's sticking up enough so that you have enough clearance for this 0.63 to be sticking up above the vise, right? And then you want to put as much material underneath there as you can, right? So do the math on 5/8 and 5/8 and 7/8. Figure out how much you can have sticking down there. Give yourself a little bit of clearance, right? So if you want to break through a little bit, you know, if you want to go to like a depth of like 0.65 or something like that, make sure you have that raised above the vise. And then I did find a nice little chart that I included in the reference files for week 4. So I'm always wishy-washy a little bit on what the actual percentage for drill holes for ream. And it seems to be about 2% is where your sweet spot is for material removal for reaming. So what that means is that if you got a 1 inch ream, you'd want the hole to be like 9/8, right, to get your ream. So this chart gives you the drill sizes for what you want. So if we're doing roughly a 1/2 inch, I think is what it is, you can come down here to the 1/2 inch for the reamer diameter, and it tells you what drill size you use basically. I think it's I can't really read it from the screen. 20-something 64. 31/64, sorry. Okay. So you can keep this handy. And then if you don't, you probably don't have one at home, but you can Google a drill chart as well. So I don't call out the tap drill size. I want you to do a quick little amount of research to figure out what a 3/8/16 tap drill is. Not a big deal, but it's just something that I want you to get used to having to reference, right? I'll try to find a good copy of like the Starrett chart that you can have digitally too, so you can keep that in your files as well. And we'll be using this more often, so you can keep that handy. Okay. With that, I think I'm ready to kind of let you go, and you can spend the next couple hours just kind of building your solids and getting ready for your master camp setup stuff. Okay. And Matt and Emily, same thing too. Give me a shout if you get stuck on anything, or if you want me to share my screen and show you anything. I'll be more than willing to do that for you.
Okay, thanks, Sean.
All right, thank you. Done.
Do you have any questions all from you guys before we start? Just kind of work independently?
No, for me.
No?
Just
Okay.
one.
Sure.
On the second operation, op 20,
Yeah.
are we flipping it over and using the vise?
Good point. So thank you. So the way I envisioned that is just turn the vise off and make a plane on the bottom of the part, but don't worry about making any kind of elaborate setup stuff. So to
Right.
your point, I'll show you real quick. So what did I say? I said op 20 was the facing. Yeah, op 20 is the facing. So technically speaking, let's go back into here and turn on just that operation for a second. So for what we're doing, here's what I would recommend you do, right? We're only facing it. So if I was going to have you build something like this, the part would be flipped over. So if let's say we're starting with the counterbore facing up, which is one thing I didn't mention. In order for you to do this in 3 operations, the counterbore has to be facing up. All right, because I call it making the counterbore on op 10. So make sure you assemble your op 10 with the counterbore facing up towards you. Okay. What this should actually look like is, you'd have this part machined off already on the bottom, and the only stock you'd have would be on this top part, right? Because you had the part flipped over and you have the excess on top. What I would do for this is just take your op 10, take your op 10 where you do all this stuff first. So you machine all your top pieces. Just go ahead and flip this over. Turn your vise off just so this is on. I don't really care about this. And just make a plane on the back and do your facing there. Okay. I actually don't even really care which operation you do it on, to be honest with you. You could do that separately anywhere you want. I probably should have made it so that you did a third assembly for this just to make it easier, but I was trying to make it, I made it harder by trying to make it easier. So go ahead and just make a plane on the back of that first SolidWorks assembly and just do a facing up on that. Does that make sense?
Yep, no problem.
Yeah. Okay. If you get hung up on that, like I said, that's not going to be why you lose a bunch of points if you get screwed up on that a little bit. I just didn't want to make you do 3 SolidWorks assemblies just for that stupid spacing stuff. Okay. All right. Excellent. Yeah. So I'll be walking around. If you have any questions, just like I said, let me know. Give me a shout. We got plenty of time to get most of this stuff established tonight. So.
Okay, Sean, so I'm just gonna work and then after that, I'm gonna share a screen with you.
I'm sorry, you broke up a little bit.
Hold on.
Sure.
I said, is it possible that I can share my screen with you later on if I have questions?
Yes, you can share your screen. Yeah. So if I end up, I can actually stop presenting, and I believe you can take it over.
Okay, okay, okay. Okay, because
So
I'm
if
using
you do want to present something,
another computer for my master and I'm looking at your presentation.
oh, so you couldn't see my screen?
No, no, I can see your screen, but I cannot share it now based on this. I have to open the
Oh, okay, okay.
into my other computer. Okay. Okay, until what time are we can do this?
Yeah, let me, 1 second, I'm just gonna take, okay. Sorry, I'm having a hard time hearing you. It might be me because I'm in the basement, you know?
I think it's my computer. It's my computer. It's funky sometimes. I said,
Yeah.
until what time are we gonna do this? Until
Oh,
what
so
time?
it's basically an open lab right now. So between now and 8:30, I'll be on the phone if
Perfect.
you have any questions.
Perfect.
Yeah.
Thank you, thank you, thank you.
And I'll be available during the week too. The only thing that you missed, I think 'cause I didn't let you into the meeting, I didn't notice that it was pinging me. So this is the file structure that you want to make sure you have. If you can still see my screen, hang on, let me
No.
put it back up for a second. Yeah, I'm going to put it back up right now. So, and I think you'll kind of follow along. So there's 3 operations to this part. So I want everybody to make 3 folders for 1 for each operation. So inside of each operation here, you want to copy all of your fixturing stuff into it in the part file. So it's kind of isolated from the other operations. You can't accidentally modify the same one over and over again.
Okay.
So you'll see like op10 has foot in it, and that's a file you download from week 4. And then we have the 3 files here for the SolidWorks assembly, which is basically the Kurt Weiss assembly, the movable jaw part, and the main body part. You basically want to create this and then copy it 3 times. And as you build these operations, you want to make sure you're reopening, you want to make sure you're opening the right operation number each time.
Copy that. Okay.
Does that make a little bit of sense?
Yeah, yeah, I got you.
Okay. Okay, perfect. And then when you go to submit this, you'll submit a zip file with all 3 operations in 1 folder. I didn't talk about that yet, but you can zip all of them together and then send that to me as a package.
Okay. All right, right.
Okay. I'll put you back on speaker so I can hear you if you have any other questions too.
All right.
Okay.
And also, I want to on the
Yeah.
other that was having difficulty with.
I'm sorry, I missed the first part.
I said the last week's work because I just need your help. I think in the last portion you send me an email about it, and I'm gonna probably ask you questions about it later on. Is that okay?
Oh yeah, sure, absolutely, sure.
Okay, thank you so much.
Yeah. If you want to, you can share your screen later and we can look at
All
it.
right.
Yeah.
Thank you, sir. Thank you.
Oh, you're welcome. No problem.
So the file structure thing is going to be super important. So it looks like. Oh, okay, sure. So all you need to do is left click on the one you want to delete, just to highlight it basically. And I find that it's a super right click right now, but there's no right. Right. So if you use the delete key on the keyboard though, you'll go. There you go. So yeah, when you're deleting the machine groups, you guys use the keyboard thing. So if you want to make that toolpath group like yours or something, yes, you just right click on machine group. You're right. And then groups. And then it will be a toolpath. And that's the problem. Okay. Perfect. So that's the structure. So that's perfect. And honestly, don't get too hung up on the next stop. Just make your op 10. You know, just a few features back basically. And then when you get to the op 30, op 20, op 30, we can kind of go with that later on if you don't want to do all. Oh, so if you go into course content, it's the right there. So if you download that, that's a Word document, which is right there. So, and if you want that print stuff, you print that. I don't know if you guys, I like to print stuff out like that, but I don't do it by default. Just do ask. It's gonna ask you every time. Then. So how do you start create technically not really. Technically not really. Yeah, you go. If you just do the stock block for op 10, that's fine. Like I said, I'm trying to let you guys have a little bit of free range. If you decide that the stock block is use the big one, in your case, probably. Sometimes it's not worth Yeah, exactly. Because like I said, the stock is mostly for reference. It doesn't modify the code in any way. It's just there for you to basically see if it jumped out. And when we backplot, we're not using the verify, so we check it, we backplot, and then we really don't. What's the as far as that goes, so when you, yeah, I mean, it doesn't give you anything other than the ability to machine it and verify. So basically the verify, yeah, correct, yeah. So if we were gonna use the verify in the comparator, then you have to have that follow block, so that up at the end. But we haven't really gotten to the point yet where we're using it. And a couple of, probably like towards the end of the semester, we'll start using that to kind of compare and see what our expected dimensions are. And you can actually type in a range, and it'll show you color coded green or red, whether it's yeah. And the only thing I really find the computer useful for is if you accidentally forget to like say you leave 10,000 somewhere, and if you didn't take that off, if you run the comparator, you'll see that right away. Whereas yeah, I think a little bit towards the end. Yeah, right. We can use it as part of our check process. But yeah, we may have done it. Yeah. It is useful. I just don't spend too much time with it. Really.
Oh, you know what? I'm going to stop recording this meeting now because otherwise it's going to be kind of useless.